Hello! In this video we'll talk about endianness. So earlier we had mentioned that memory is byte addressed, and the question is, how do we number the bytes within a word? So there are two orders called Little-Endian and Big-Endian. In Little-Endian, byte 0 of a word is the least significant, byte 3 is the most significant. In Big-Endian, byte 0 is the most significant and byte 3 is the least significant. In both cases, the word addresses are the same. Word 0, word 1 is at address 4, word 2 is at address 8, word 3 is at address C. But the order of the bytes within the word have different addresses. So it doesn't really matter how you do this, except that if you have two different systems that need to share data, and one is Big-Endian and one is Little-Endian, and you look at bytes within the word, then they come out backwards. So for a long time, computer architects had something of a religious war over which endianness was correct. Some thought Big-Endian was more natural, some thought Little-Endian was more natural, and they came up with all sorts of contrived reasons. But really, when you get down to it, there's no reason that one of them should be better than another, and it's just an arbitrary choice. And I used to work with a computer engineer, a very clever fellow named Danny Cohen, who coined the term endianness. It's with reference to Jonathan Swift's satirical novel called Gulliver's Travels, in which there were warring tribes of Little-Endians and Big-Endians who broke their eggs on the little end or the big end and were in warfare, accusing the other side of having the wrong way to eat their egg. So computer makers went through this warfare for a while, and now many computers have the ability to swap endianness as necessary. There's one way you can tell the endianness of your computer. Let's say you had a word in memory, 2, 3, 4, 5, 6, 7, 8, 9. If you're on either a Little-Endian or a Big-Endian machine and you load that word, you'll get the same thing. But if you store that word into memory, starting at byte 0, address 0, and then you load byte, say byte 1, if you're in a Big-Endian system, byte 1 would be 4, 5. You'll get back 4, 5. If you're in a Little-Endian system, byte 1, you'd get back 6, 7. And so that's the place where things can go wrong between endianness.